Hi, everybody. My name is Nathan. I'm one of the marketing managers at Data Science Dojo. We're really excited to have David Crossley here. He's an AI architect at Microsoft. Going to be talking about building trustworthy AI solutions. If you do have any questions and you're on the Zoom webinar, feel free to use the question and answer function. That's actually better than chat because it just helps us keep things organized. If you're on YouTube, feel free to just go ahead and comment your questions. At the end of the session, I'll do my best to ask David those questions. All right, David, feel free to get started.
All right. Thanks, everyone, for coming, and good afternoon. So we're going to talk about trustworthy AI solutions today. And thank you to Nathan and the team for having me this afternoon. So to get us started here, I'll just give you a little bit of background about myself. So as Nathan mentions, I work at Microsoft. I've been at Microsoft almost 20 years. In a variety of different roles. The most current role is as an AI architect focused on our Dynamics products, mostly on the ERP products. So Dynamics Finance is the primary product that I work on. Over the last few months, I've had the opportunity to work for another good company, excellent company with our hosts here, Data Science Dojo. So I've been doing some part-time instructing for them, and that's been a really good experience so far. And it's a great company to get engaged with from a training perspective. I do a little bit of blogging at this lakedatainsights.com, and there's two themes here with the blog. One is data science. So I started this particular blog a couple of years ago when I was working on a master's degree in data science, and I kind of documented some of my journey through that, and now I document different tools that I might be using and things like that. And then the second theme is the lake theme, and which is the picture you see there. So I live in the state of Minnesota, which some of you may know as the land of 10,000 lakes. So I tend to take advantage of some outside opportunities and get some pictures on the blog as well. So come for the pictures and stay for the data science, hopefully. And then you can see my contact information down there in the bottom. So feel free to reach out, and I usually post there if I do have a new blog post, which is every couple of weeks or something like that. So today we're going to talk about the speed of trust and how trust can really improve our interactions, both from a perspective of human to human, and how important that is, and some context around that. But then also we'll get into the meat of this discussion, which is AI and the importance of trusting your AI solution, how that compares to what we think about when we think about human-to-human trust, and how similar and how it's different. And then we'll use a framework of some guidelines from Microsoft Research to talk through some ideas about building trustworthy AI and give you several examples around that. So that's what we're going to do today. And to kick us off, I want to talk about one of my favorite business books that I've read over the years, and even took a training class at Microsoft at one point, and that's The Speed of Trust. The book was written by Stephen M.R. Covey, who's the son of Stephen R. Covey, who's the 7 Habits of Highly Effective People author. So it's part of that family. And what I like about the book is it really highlighted how with trust you can do things much faster, right? With much less friction. So, for example, if you think about your personal interactions, I have a home contractor that has done several projects for myself and my family, and does really good work. And it just makes it easy for me to go work with that contractor in the future. I don't go out and get a bunch of quotes from a bunch of people. I don't even ask him to give me a quote, because I know he's going to do a good job and deliver and be reasonable with his pricing. So you build that trust, and it goes a lot faster. Another example, and personally, is of all people, I have a car salesman that I trust, and the dealership behind that salesman I trust. And that just makes it a lot easier to go shopping for a car. Then if you think about it from a business perspective, right? Think about the people that you really trust in your organization. Maybe it's an employee, maybe it's a peer, maybe it's a manager, maybe it's a vendor. Think about how much easier it is to work with those people than it is with somebody who you don't have that level of trust. You don't have to do a lot of status checking, that you don't expect a report from them to tell you how things are going. You don't stay up at night worrying about, did this get done? You just basically give somebody a task or responsibility and they deliver it. And you know, if there's issues, they'll raise it. So the speed of trust really is important with business to business interactions or interactions within business. It's really kind of that grease that removes the friction of the gears that clash together sometimes when you're trying to do business. So it's a really good book. It's been around for quite a while. Pick it up if you get a chance. Tell you a little bit more about it. He frames it in this concept of the 4 cores of credibility, and he visualizes that with this tree that I grabbed off his website. And credibility is made up of character, which is, I think, what we typically think about from a trust perspective, right? That you think about people with integrity, and you think about people who have an intent that aligns with helping people and not being a selfish intent, but an intent that's beneficial to both people involved. But the other part of it is competence, and that's what you really need to gain that speed, right? You can have high integrity people that come along but don't do good work, right? And then you don't trust them because you don't trust the work that they produce. So competence is the other half of trust and credibility, and you have to have competence in the capabilities to get the job done, and then you have to prove those results over time. So that's the 4 cores of credibility that he talks about, and then goes on to talk about 13 behaviors that inspire trust. We're not going to drain all this, but there's a few things now as we start to transition to AI scenarios that will come up again, right? Things like talk straight, create transparency, deliver results, get better, confront reality, clarify expectations. All these things are themes that you're going to see as we go forward and start talking about the next phase here, about humans trusting AI, right? So that's the question that we have to answer as data scientists and machine learning engineers and the like. How do we get to the point where the people using these AI solutions can trust it? And I'm not talking about robots or like this picture shows, or self-driving cars, or even military applications or healthcare where the situation is highly sensitive, where trust is utmost importance. There's the everyday AI that we all encounter, ads and recommendations, and our map app telling us how long it's going to take to get home and what route we should take and things like that. All those things require us to trust it in order for us to use it. And then there's business scenarios, which is what I worry about, right? So we're trying to build AI capabilities within our Dynamics product, and we're trying to make them accessible and usable and trustworthy for people who don't know anything about AI, right? They're business professionals. They have no expertise in this area. So how do you bridge that gap from this data science AI mumbo jumbo to something that they use and trust and can interact with over time? So that's the thing we have to accomplish in order to really be successful with our AI features. And I'm not alone in that perspective. There's some pretty senior level people. Satya Nadella, our business model depends on one thing and one thing alone, which is the world having more trust in technology. Out of IBM, human trust in technology is based on our understanding of how it works and our assessment of its safety and reliability. To trust a decision made by an algorithm, we need to know that it's reliable and fair, and that it can be accounted for, and that will cause no harm. That's a pretty high bar, right? To think about trying to build that trust so that people understand, but yet not overwhelm them with the details of what we deal with every day in our worlds. Google, these moments often occur when someone sees their data used in a way that appears as if it isn't private, or when they see data they didn't know the system had access to, both of which can erode trust, right? So it's this point that trust accumulates very slowly and it can be blown very quickly. And those types of situations where your data is exposed, that's where you're going to lose trust in a big hurry. And last, Salesforce, to build trust, create an easy mechanism to give feedback on predictions your user believes to be inaccurate or unhelpful. So that's another aspect of this, right? That if things aren't right, you need a way for the users to provide feedback into your AI solution. And there's lots of research on AI trust. I'm standing on the shoulders of a lot of work that's been done at Microsoft, including some research on AI trust. There's a paper just presented this week by a couple of my peers in our division at Microsoft about the AI trust score, something we're starting to use in our Dynamics product area. So AI trust score is built on job efficiency and effectiveness, right? So kind of going back to that competence idea from before. Understanding and control, so that you know what's going on and that you can control it, you can provide feedback. That's going to help with your trust. And then data protection, the Google comment about making sure that what you put in is protected. So all those things accumulate to an AI trust score. And this research paper that went into this CHI conference this week showed how that AI trust score correlates very closely with user satisfaction in the AI feature. So in order to have a successful AI feature, you need trust is the bottom line. So let's look at those 4 components of credibility again, and just map that into AI features and how we should be thinking about that. So if you think about integrity, to me, that's really the company or the people behind the algorithm or the AI feature. So does the company walk the talk, so to speak? Does it have, do you trust that company? Does the company represent itself well in a variety of social situations and have that integrity? Second part is intent. Do you believe this AI capability is here to help you, or is it here to sell you what they have on the shelf, or what is the highest margin available, or what's the most profitable for the company? You know, you have to intent. You want mutual benefit, and AI capability should show that. And then the competence piece makes a lot of sense here too, right? You're not going to trust any AI that you don't believe has the capability to help you or proves itself over time, right? You go back to thinking about that, your map app, if it tells you you're going to be home in 15 minutes and it's 45, if it tells you to go to route A and it takes you a lot longer and you end up in an even worse traffic jam, it's not going to take long before that trust is gone, right? And you no longer have that opportunity for speed and moving forward. So I think there is a parallel, right? I think that human to human concepts apply also to human to AI concepts when it comes to trust. But I think there's some differences too. And this research paper kind of highlights that. And I think a lot of times as humans, especially those of us who are maybe trustworthy by nature, you give people the benefit of the doubt, right? You trust them until they do something that doesn't earn your trust anymore. Now, it's not always the case, right? Some people are not like that, but I think you are more likely to do that than you are with a technology solution. With a technology solution, you are going to distrust it until it proves itself to you. And so you have to make sure from even before use that you set expectations for what the system can and can't do. When it's first being used, you're going to have to realize that the customer is going to judge you and may never come back if you do not provide value right away. And then over time, it needs to get a little bit better. But over time, hopefully it becomes part of that person's routine and they start to trust it and they believe it when the map tells them it's going to take, 15 minutes to get home if you take route A. And more often than that, that works. Then the trust exchanges are going to go up and you're going to end up building that trust in AI features. So there's similarities and there's some differences between the two. I definitely think there's some parallels, and the concept of speed comes through in both cases, right? You trust your AI, you're going to move a lot faster. So the rest of the talk, I'm going to focus on some guidelines for human AI interaction. So this comes out of it, Microsoft research. I'm going to have links for all this stuff in the deck, and Nathan can share those later on. And I found this to be a really good set of guidelines. It kind of underpins a lot of the work that we do at Microsoft. There's 18 different guidelines, which is more than the 13 behaviors in Covey's work. So apparently this is even harder than human-to-human interaction. But I think there's some good pieces here, and I'm going to walk through these in more detail and give you some examples of how this could work. You can see how it phases through four different steps. There's initially, there's during interaction, there's what to do when you're wrong, and then over time, how should you be building trust in your AI solution? So initially, there's just two boxes here, and it's make clear what the system can do and make clear how well the system can do what it can do. So this is all about setting expectations, right? Clarifying expectations. This again was something that Covey talked about in those behaviors. So for example, make clear how well the system can do what it can do. I'm going to give you a couple examples out of the gate here from Dynamics, and then the rest will be some other examples that I've pulled from various sources. But in this case, it's a solution that we provide in Dynamics where we essentially provide a template and the customer trains a model based on his data. And he gets back a grade, right? So we don't want to give people, some low level R-squared type metric, right, that nobody's going to understand unless you're a data scientist. We want to give them something that is meaningful. And this is a multi-class classification problem. So accuracy is the easiest thing for people to understand, right? How often did your model get the answer right in the test set? But we all know that can be misleading, right? If I have a score in accuracy of 80%, that could be really great if the most common class is 40 or 50%, and it's a well-distributed type solution. But if I have one class in my multi-class that's 75%, and this gives me 5% over, just guessing everything to be the same thing, that's not so great. So what we do in Dynamics is we actually depend on a Power Platform capability called AI Builder for a lot of our AI capabilities, and they provide this grading system that helps people understand how well the system can do what it can do. In this case, 80% is a B, kind of aligns to what you might expect in school, but it's based on the data set. It's not fixed for every scenario. It looks at the data set, looks at the makeup of the different classes and gives a grade on that. So it's a really good starting point for identifying how well the system can do what it can do. They have the opportunity to improve that as they go along. So that's an example there. Okay, moving on to the next phase during interaction. So when somebody's interacting with an AI capability, you want to time services based on context. You want to show contextually relevant information. You want to communicate in relevant social norms. And of course, you want to mitigate social biases, right? So you want to not produce a biased solution that could produce harms to any given individual. So contextual information, I'm going to give you a little bit more detail on the other end of our dynamic solution. So this is that model that I showed you a couple slides ago that builds a model for whether a customer is going to pay their bill, a customer payment predictor. So when we show probabilities for a given bill or invoice, we show a bunch of related information. We show the probabilities that you get out of the model. You show the factors that influence those probabilities. You show some context on the model itself and how old that model is. And then you can give some historical information, some descriptive statistics on the customer. So all this helps build confidence. If the predictions align with what the historical behavior of the customer is, and all these other factors. You also can think about, do these things make sense? Is amount something for $268.13? Is that really a factor in the prediction? Maybe, maybe not, but you're trying to start to combine your domain knowledge with the prediction to see if it makes sense. Regarding mitigating social biases, that's a hard problem, right? We know that our data sets are biased. We know that the data scientists can be biased. So we need tools that'll help us improve fairness of AI systems. So one example is this open source capability called FairLearn. It focuses on the harms that could potentially come as a result of the AI service. It recognizes that there's no optimal solution, focuses on what the downside could be, a gender-based thing like the first example of a voice recognition system, or a job screening thing, which could be gender, could be racial, could be age, right? There's lots of opportunities that things could go wrong there on the allocation side. So this is a good tool set to go look at. It has these tools that will produce some descriptive statistics to see how well your algorithm's doing given your training data and test data. It also has some algorithms to try to balance this idea of accuracy versus fairness, right? Because you're probably, if historically all CEOs are white males in their 50s, that's all the training data you have, right? So you're gonna sacrifice some accuracy to get the bias out of the system, and it has some algorithms that'll help to try to balance that out. So this is a good site to go and just start to look at those tools and start to think about how social biases can come in. Okay, the third area is when wrong, what do you do to help build trust in your AI solution? So first parts 7 and 8 are about invoking and dismissing the AI feature. So you want to have the people to have control, right? That was part of that AI trust score, is giving people control. Correction falls into that as well. And then also don't overstep your bounds, I guess, from an AI solution perspective. Scope services when in doubt. If you're not sure it applies directly, don't assert an answer that could lead people astray. And then the last one, which is where I'll spend most of my time, make clear why the system did what it did. So this to me applies to a lot more situations just when wrong. I think you need this throughout in order to build trust in the system. So I went through and I spent a little time doing something I haven't really done when I'm browsing different websites, and that's digging into some of these background information that most sites have. So here I'm on Amazon. I was looking for a lighting capability for my home office, since we're spending all our time on Zoom and Teams. And this came up. It was a sponsored ad. You're seeing this ad based on the product's relevance to your search query. Okay, makes sense. I searched for that. I got it. That makes a lot of sense. Another example, I think this is from Facebook, an ad from Prana, the outdoor clothing company. Why did I see this? Well, you may have visited prana.com. That could be true. Probably it was my wife, actually. Prana is trying to reach people ages 18 and older, and they're trying to reach people whose primary location is the United States. Okay, that's pretty understandable. So I think that's making it clear why I'm seeing this. Now, what's a little bit more mysterious to me is Kool-Aid Man. So Kool-Aid Man shows up on my Twitter feed from time to time, and I've never really understood why, and I've never really taken time to try to understand why. Well, it turns out Kool-Aid Man wants to reach people between the ages of 25 and 49 and located in the United States. Well, I don't think Twitter knows my age. I'm not quite in that age group, but it's pretty broad range. I'm not that far off. So I get to see Kool-Aid Man for whatever reason. So it's clear why. The rationale behind the why is not clear, but that's all right. Another example also from Twitter is an E-Trade ad. And this one I found less helpful. One reason you might be seeing this ad is that you're part of or similar to an audience from E-Trade. Well, what does that exactly mean? How am I similar to the audience? Why did I get targeted for this ad? That's pretty vague terminology. It doesn't really answer the question to what I was going to find out, to why I got this ad. So that one wasn't quite as good. It also goes on to say it's United States and 18 and over. Doesn't really narrow it down a whole lot. So I think it was pretty interesting to drill into some of these and see what people are doing as far as trying to make clear the system, why the system did what it did, and give you some more context. This is a topic that deserves maybe not just one webinar, but several webinars, right? There's a lot of work being done with interpretability or explainability of ML solutions. This is another open source capability that originated with Microsoft Research that has a bunch of tools that help you explore your data and your model, gain understanding of what the model can do. And it helps in a lot of different ways. And I'm going to give you a little better example of this in a couple of slides to give you some more detail, but it can help with debugging, can help with feature engineering, the fairness issues, trusting the solutions, right? There's a lot of things that are important from an interpretability standpoint. Interpret ML talks about glass box versus black box solutions. It provides some new algorithms that are more glass box in their nature, as well as the capabilities like SHAP and Lime and others that are built for explainability of black box solutions. So like I said, there's a lot here with interpretability to work through and talk about. So we'll maybe save that for a future session. Okay, so the last group here over time is a pretty big group, right? There's 7 different boxes here. And, I look at these things as examples of what robust solutions really do. They are the ones that people really start to trust because they start to optimize for the user over time. They remember what you've done recently. They learn from what you've done. Something that you don't think about a lot, or that maybe a lot of us as data scientists don't think about, is updating and adapting. So in the the SaaS software world, that's a really important thing, that you don't update your software too dramatically in one step so that people lose the sense of where they are and how to use the system and things like that. You don't completely rearrange the user experience in one go. You might do that over multiple releases. Well, think about retraining a model, right? That's a pretty simple thing that you might do regularly in order to keep up to date. But every time you retrain a model, you start to get different answers, right? So my customer payment predictor, maybe it was 50% payment on time probability yesterday, and now it's 30%. What happened? Well, the model might have got retrained and new information came along, and it's post-pandemic, so the behavior is a lot different and things like that. But if you don't have explainability, and this isn't explainability within a model, it's explainability from model to model, that's something you're going to have to think about building into the software more explicitly. You want to provide the ability to get granular feedback. You want to communicate the consequences of user actions, provide those global controls, notify users about changes. All these things help improve the trust in the solution over time. A lot of what I've been talking about here isn't just about the software. A lot of it comes into play with the documentation and how you document your capabilities such that it's tailored to the right audience, so that you give enough information for them to understand but not be overwhelmed. So an example of this, encouraging granular feedback. This is back at Amazon. So I can provide feedback and I can say, this isn't what I was shopping for. Even though I searched for conference lighting, it might not make sense in this case, but you can have that option to provide that feedback. You also can provide global controls on Facebook, for example. So what can you do? You can hide all ads from this advertiser. You can make changes to your ad preferences. So all these things are a possibility with a lot of the social media and more advanced capabilities. Now, how much of that's getting built back into our business solutions that we're providing or that we're implementing within companies is the next question that we have to understand. So the last thing I'm going to cover here, and we'll be done here long before the hour, is talking about a special class of solutions that is AI-assisted scenarios. So this is a really important type of solution in businesses, right? I'm a strong believer in that you want to combine human intelligence and artificial intelligence, that people's domain knowledge and understanding of their business needs to be used and applied, not just in the algorithm, but in the decision making, right? So you bring in the perspective of the human, you bring in the perspective of the AI, and together a better decision comes out. HBR calls that collaborative intelligence. I like that term, where you're bringing that human and artificial together. I like to think about, instead of a domain expert, you're a data informed expert. But the bottom line is you want a kind of a better together scenario, right? Where the humans and the analytics together bring to a better decision, which now you're wondering, why is this Big Ten versus Gonzaga icons on my screen? So my favorite sporting event of the year is March Madness. And I run a small pool with some friends and coworkers around the tournament, and try to do a couple other things associated with that. It makes the tournament more enjoyable if you have some skin in the game, so to speak, about who you want to win. So a few years ago, when I was just starting to learn about data science, I decided, well, I don't watch a lot of basketball during the year, even though I really enjoy March Madness. So I get to these pools and I don't really know who to pick, right? You maybe find some article someplace and you start grabbing names. So I decided I was going to build a machine learning capability to help me with this. So I used some historical information that Kaggle runs an annual competition. They have a bunch of data there about who's won and lost all these games over the years. So some labeled data. I pulled in some advanced basketball statistics that I found from actually Ken Pomeroy on the web. And I kind of started to model that together into a machine learning capability. And that's been pretty useful for me. It's a pretty simple model with not a lot of inputs, but that's kind of how I like to run these things, right? Because I have a bias towards simplicity. So I'd rather have some well-developed input features that are interpretable by themselves, have a model that's more or less a glass box model, right? That's understandable, that I can look at the pros and cons that it determined, and then reason about it, right? That's how AI assisted scenarios get better, right? Because you can understand a little bit about the model and go from there. So this year, I did my usual routine where I pulled in all my historical data. I run it through a few different algorithms to see which gives me the best accuracy, and then I use that to pick my games. Well, this year, the most accurate algorithm using the historical data showed Gonzaga, who is the prohibitive tourney favorite, right? They're undefeated, the #1 overall seed, as being maybe the 20th best team in the tournament if you look at all the games, because you figure out every possible game combination. And just about every Big Ten team, I live in Big Ten country, so I might have a little bias towards the Big Ten, but I knew they weren't going to be such that every Big Ten team was better than Gonzaga. But that's kind of what my model was telling me, that almost every Big Ten team that was in the tournament was better than Gonzaga. So I started questioning that, right? So this is the case where I'm both the developer and the user of this model. And as the developer, because I had some domain knowledge, right? So I was using this as an assist to me. Plus I had a transparent glass box model, plus I had features I understood. I realized that offensive efficiency, which is something Gonzaga did really well, didn't really show up as a prioritized feature in this model, which actually was logistic regression. What did shine through was strength of schedule, which of course the Big Ten supposedly had. So I ended up choosing a different model. I chose a model that lost a couple percent in accuracy, but gave me something that made sense, a little bit aligned to my intuition, right? So I as a domain expert, as a developer, chose another model to do that. Now, the next part of this equation is the answers, the predictions it was giving me. And this is the case, now I'm the user of this algorithm, this AI solution, just like people are users of our payment predictors, all kinds of other things that we might be developing in order to help business users. And when it's AI assisted, you have to start to develop some intuition about when the AI is good and when you might question it, right? And some of that might have to do with your biases that you brought to the table, and maybe it's just wrong. But other times there's things that that maybe the AI doesn't know about. It doesn't know that there's a pandemic going on, for example, and that the industry that this customer in is being hit very hard, right? That's not something that you had historically in the model. So you have to develop this intuition, you have to calibrate the trust. And what was interesting as I came across this research paper as I was prepping for this, effective confidence and explanation on accuracy and trust calibration and AI-assisted decision-making. And what the article says is that if you provide confidence information with your AI prediction, they found that to be more impactful on trust than local explanations. So in my case, I get a confidence level of team 1 beating team 2 in every given combination, right? So I can look at that probability, and if it's 55%, yeah, I might override it, right? I might say, you know what? I think this team's really better. Maybe I just like that team and I'm going to pick them. I'd rather cheer for them. But if it's 95%, the model's highly confident, it's going to be a lot harder for me to override that. And I found that would be more valuable than looking at the individual features and which features are most impactful in each one of my predictions. So I basically concur with the model, if you will, that confidence information, or the paper, excuse me, that confidence information is more important than local explanations with that. So that's just this. If you're going to achieve collaborative intelligence, right, you have to think about the trust scenario in a little different viewpoint than some of the other cases. So it's all context dependent. All right, so just to wrap up here, 2 key takeaways. I think this 4 cores of credibility is an interesting way to think about how you ensure, how you evaluate your AI trust, and realize that you need to have good results, good capabilities, that your intent should be there. The intent shouldn't be, as a user, you shouldn't think that the person who developed the AI or the company that developed the AI is trying to take your job, right? It's there to help you. And that you want to have AI solutions that come from company and people with integrity. So it's a good, simple model to think about AI trust. If you are able to check all 4 boxes, you're going to get speed, right? You're going to get faster decision-making, better decision-making. And then, I've gone through a lot of different resources here and not in a lot of detail. So this is a set of the resources I went through. This AI guidelines was the 18-box set of guidelines framework for you to start thinking about some stuff. There's more detail at the site. Fair Learn, Interpret ML, and then the research papers that I referenced. All those pieces are available for you to go and research. So with that, I will wrap up here. We've got a few minutes left for questions. Okay, so just looking at the Zoom here. First question, can AI improve trust in state? And I'm not quite sure what you're after there, Jorge. If you, Nathan, can people unmute and ask?
I might be able to unmute Jorge here. Let me.
Oh, during a pandemic. Okay, so that's a second part to the question. The pandemic thing is interesting in general, right? It is how, I mean, machine learning is based on history, right? And when you go through unprecedented history or unprecedented times, history isn't nearly as valuable, and you have to get smarter about your machine learning and maybe produce, train on less time frame over the last few months. You need to have some additional information that you didn't have in your model, like the industry piece that I mentioned before. So it's a challenging place for machine learning algorithms in general, and trust in that time period is going to have to be earned, but you, as a developer, you're going to have to think about reacting to that. So I guess I'll say that about the pandemic. I'm not exactly sure the context.
David,
yeah, go ahead.
I was right now watching a conference from the British University that talk the way that we can make a journey to trust the government. But I think AI and your knowledge and your experience will be very interesting right now in many countries where the pandemic is making a big damage in the trust of institutions. Maybe technology has some answer.
Yeah, it's a really good question, Jorge, and I want to believe that. Yet, you look at all the doubters in science in general that has shown up through the course of the pandemic, and I think there's opportunity where we can put forth the facts that matter, and algorithms can help with those facts that matter that could possibly help. But if people have this level of distrust with science as a starting point, it seems like it's a bit of an uphill battle. That'd be my thought on it, but it's just a thought.
Thank you.
Yes. Would you say the principles of trustworthy AI can power community engagement initiatives around AI? And if so, ideas how to achieve this? So, Afia, can you explain a little bit more about the community engagement initiatives that you have in mind?
Sure. Just, rallying potential users around an AI software and getting them engaged with the software.
Well, yeah, I do think so, right? I mean, that's it's almost every scenario. Trust where AI comes into play, you have to have trust. Whether it's a business scenario, like I've talked about a lot, if it's the self-driving car scenario, right? I mean, who's going to get into a self-driving car if you don't trust the underlying AI or get on the road with that? So any type of solution that you have, you need to have, it's an essential ingredient, right? It's a starting point for people to actually go and use it. So yeah, definitely there. It's just applying the principles, right? If you are you're developing something that has AI in it, you apply the principles. If you are working from a community perspective to develop AI awareness and AI engagement, then teach that, right? Teach the power of trust and the need for trust in those solutions, and really bring that forward. And I think it'll resonate with people.
Thank you.
You're welcome. Anything else out there, Nathan?
I'm not seeing any on YouTube, but I do see Ahmed Mapara just posted something in chat, and I'll read it out to you.
Okay.
So how do we build trust when we know the same AI models can also be used for potentially things that can cause destruction to society?
Well, it doesn't sound like a trustworthy model to start with, right? I mean, there's been cases of, in the criminal justice system, for example, where there's been prediction algorithms that are supposed to help judges decide what sentencing should be, and it's based on how likely the person is going to commit another crime in the future, right? So that's an algorithm that has been shown to have some racial bias by some other analysis. Is shown to have a number of different flaws, right? So that can be harmful, right? So it's an unfair solution. So that's not a trustworthy thing. I think you have to evaluate every algorithm for its overall benefit and who it can potentially harm, and if it doesn't deserve trust if it is going to potentially harm someone, and it's a reasonable use case for that to happen. So I would say you can't, and you should find a better solution.
Perfect. And we also have someone asking for, I think it's the Chicago paper that you mentioned.
The Chicago paper. Let me just go back here. Or Kai?
Yeah, sorry, that one. I saw the abbreviation went for Chicago.
I got it. Yeah. So let me just go click on this link here. I don't know if that paper is published beyond the program here. So this just is this week, right? So this just came out. I happen to have internal connections with the authors, so that's why I have that paper. Nathan, I will see if that's been published in a public place at this point or in the future, and get that shared to you, and we can get that out.
Sure, yeah, and we can put it just so everybody knows we are recording this, and when we post it on our website, we'll include all the links that David has shared with everyone. Okay, and I think that's all the questions.
Great.
We have. So thank you everyone for joining, and big thanks to you, David, for taking some time out of your busy schedule to talk with us about trustworthy AI. For those of you who don't know, we do have more upcoming webinars. Our next one will be on June, I believe it's on June 2nd at noon, so the same time. It's going to be on data analysis and challenges in cybersecurity. We have another presenter, Jordan Ross, that works at Microsoft. We'll also have some upcoming events at the end of June and beginning of July. They're not on our website yet. I'm still figuring out some of the finer details of them, but they should be up on our website probably next week. So thanks again, David. Thank you, everyone, and I hope you all have a good rest of your days.
Thanks, everyone.